Industrial Bakery Simplified.
Hey there, and welcome. Have you ever stood in the bakery aisle just completely baffled by what really makes a cookie different from a cracker, or a biscuit from, well, another biscuit? You're not alone. It seems like total chaos, right? But today, we're going to clear all that up. We're going to demystify the entire world of baked goods with a really simple but powerful tool I like to call the Baker's Blueprint. I mean, just look at these names. It's a total mess, and it changes depending on where you are in the world. What one person calls a biscuit, someone else calls a cookie. And where on earth does a wafer fit into all this? Look, this isn't just about winning a trivia night. If you're a food producer, getting this stuff wrong means you could create a completely different product than the one you are aiming for.
Okay, let's just dive right in with a perfect example. See this? In the UK, this is a classic biscuit, no question. But if you ask for a biscuit in the US, you're probably going to get a soft, fluffy thing that you eat with gravy. What the British call a biscuit, an American would almost definitely call a cookie. So, how are we supposed to make sense of any of this?
What we need is a roadmap. So here's our plan. First, we are going to untangle all that tricky terminology. Then, I'm going to introduce you to the Baker's Blueprint itself. We'll explore its two extremes, the strong and the crumbly. We'll also look at some really cool exceptions. And then, most importantly, we'll see how this blueprint is a practical, must-have guide for anyone who actually makes these products.
All right, so let's tackle the names themselves. Why is it all so confusing? Well, the answer, as it so often is buried in history and language. So get this, the word biscuit literally comes from Latin for twice-cooked bread. You know, like those super dry, hard things sailors used to eat? So in the UK, it just became this huge catch-all term for everything. Cookie, on the other hand, comes from the Dutch word for small cake. And that makes total sense for the richer, sweeter things that got really popular over in North America. The bottom line, the names are all about history, not science. And that is exactly why we need to just forget the names for a minute. Seriously, to really understand and classify all these products, we have to look at what's actually happening inside the dough. And it all boils down to the relationship between just two key things. First up, we've got something called enrichment. This is just a baker's way of talking about the amount of fat and sugar in a recipe. The more enrichment you have, the richer and more tender your final product is going to be. Just think about the difference between a simple, plain water cracker and a buttery, melt-in-your-mouth shortbread. That difference, that's enrichment. And our second factor is gluten. You've heard of it, for sure. When you mix flour and water, you start to form this amazing protein network. Gluten is what gives dough its stretch, its elasticity, its strength. A ton of gluten development gives you a chewy, strong dough. Think bread. But very little development gives you something that just crumbles apart. Okay, now this is where it all comes together. This right here is the Baker's Blueprint. It's so cool. On one side, we've got enrichment going from low to high, and on the other, we have gluten development from minimal to fully developed. And guess what? Almost every single product we've talked about fits somewhere on this grid. It's basically a map of the entire baked goods universe.
So let's start our journey in that top left corner of the map. Low enrichment and lots of gluten. This is the land of doughs, where strength and structure are absolutely everything.
These kinds of doughs don't have a lot of fat and sugar. And you have to mix them and mix them and mix them to really build up that strong, stretchy gluten web. This is what lets you roll them out into super thin sheets, layer them up, and cut them. And all that work bakes into that amazing, crisp, snappy texture you get in a good cracker.
And here's the perfect result. That super satisfying snap you hear when you bite into a cheese cracker, that's not some happy accident. That's the sound of that well-developed gluten network literally shattering. The gluten is what provides that crisp, brittle structure. Okay, time to pack our bags and jump to the complete opposite corner of our blueprint, high enrichment, where we want as little gluten as we can possibly get away with. Welcome to the world of short dough. Now, this is the really crucial part. In these recipes, the fat and sugar are basically acting like little bodyguards. They surround the flour particles and physically block those long, strong gluten strands from linking up and forming a network. So the goal here isn't to build a structure, it's to prevent one from forming. And that's what gives us that delicate, crumbly texture that bakers call short. You cannot ask for a better side-by-side comparison than this. On the left, you've got bread. That strong gluten network traps air, creating that chewy, open structure we all love. On the right, shortbread. It's dense, it's crumbly, because all that fat stopped that network from ever being born. It's amazing. One is built by gluten, and the other is built by stopping gluten.
This digestive is the poster child for a short dough product. The dough itself is plastic. You can mold it and it'll hold its shape, but it has zero stretch. If you tried to pull it, it would just snap apart. It's got just enough structure to be formed, but none of that gluten elasticity.
Of course, the world of baking is wonderfully creative, so not everything is going to fit perfectly into our two main boxes. So let's check out a few really fascinating outliers that play by a different set of rules.
First up, lamination. With this technique, instead of mixing fat into the dough, you fold huge sheets of fat between layers of dough over and over again. Then, in the oven, the water in the dough explodes into steam, pushing all those layers apart and creating that incredibly light, flaky texture you find in something like a croissant. It is a true structural masterpiece.
And then you've got things that don't even begin their life as a dough. Wafers, for example, are made from a super thin, liquidy batter that gets poured between these really hot engraved plates. The structure here has nothing to do with gluten. It comes from the super fast cooking and drying process. And finally, you get the awesome hybrids. A Jaffa cake is a perfect example. Is it a cake? Is it a biscuit? Well, it's kind of both. It sits right on the borderline with a fatless sponge cake base and that biscuit-like topping. These products are all about blurring the lines to create a totally unique experience.
Okay, this has all been super interesting, I hope. But why does it actually matter? Well, if you're a commercial food producer, this blueprint isn't just some fun theory. It is the fundamental playbook for making consistent, high-quality products day in and day out.
Knowing where your dream product sits on this map basically dictates every single major decision you have to make. For a cracker, you're going to pick a strong, high-protein flour and mix the heck out of it. For a shortbread, you're going to grab a soft, low-protein flour and mix it as little as humanly possible. This blueprint tells you exactly what ingredients, equipment, and processes you need to use.
It honestly just boils down to this simple three-step process. First, you have to define the final texture you're shooting for. That decision immediately tells you what kind of ingredients you're going to need. And those ingredients create a dough with very specific properties, which then tells you the right machinery you need to form it. From a simple idea to a finished product, the blueprint is your guide.
So, the next time you bite into a cookie or a cracker or anything in between, you'll know the science and the strategy that went into creating that perfect texture. The mess of confusing names suddenly gives way to this elegant, simple system of enrichment and structure. And this isn't just a way to classify things, it's a map for creation. So the only question left is, where on the map do you want to go next?